Hello everybody. In this session we are going to learn how to access applications running on a HPC, high processing compute. You are working at home, but you want to access a resource, an internal resource running behind HPC. For example, you are running a local large language model on a GPU, but this resource is behind a network that you cannot directly access from your home. Today we are going to learn how we can make this access happen. In our case, we are using resources on Alvis. In order to connect Alvis, what we need? SSH credentials, right? SSH, our username. This is known as Chalmers ID as well. Then cluster. In our case, this year in 2026, we are using Alvis 1 C3SE Chalmers.se. This is the server we need to connect first. So as we have our usernames and passwords, we can use this command to access. But what we would like to make it easier, we want to, for example, in order to write full name of the server, you can just give an alias like Alvis1, SSH Alvis1, then you can directly connect. In order to do this, we need to create a folder in our home directory. Once we put a dot in front of a folder, it becomes hidden.ssh config. Config is a configuration file where we write our server names, for example, host Alvis1. If we use SSH space Alvis1, like that, SSH Alvis1, then we can connect to our remote computer. How this happens? Because in hostname parameter, we are giving the full name of the server. Second, we provide the username. Okay, what is the password? Normally, this screen should ask me password, right? But it is not asking. Why? Because I need to quit from Alvis. Here I will list the content of the config file under my SSH connection, cat SSH config, right? Here is my remote computers, Alvis1 hostname. This is my username and this is my identities file. So I am using public private key authentication. Here, this is the public key or private key. This is the private key. I need to upload the public key to the remote server, to Alvis1. Whenever I want to connect with my private key, Alvis just verifies my private key by just using the public key. And public key is stored under authorized keys in the remote server. And these settings helps us for various purposes. For example, in the remote computer, I want to have ZSH instead of bash, then HPC servers. Then here, every 1 minute, I send a heartbeat to the Alvis, so my SSH connection does not drop. For example, sometimes I may need to do some research on the web to sort out some problems. Meanwhile, my SSH connection is open. So in order to prevent SSH connection hangs on, I need to put these configurations here. Here I keep my public and private keys. Why? If something happens to my public key on the remote computer, I can upload it again. And my private keys are here also that I can use for authentication purposes. Clear. Come back to the manual. Here, as you can see, SSH Vera 1. So this helps us authenticate easily without writing the hostname. But in this case, you will be prompted for password. In our case, if we put our identities file here on our SSH configuration, so we bypass password checks. Okay, when it comes to how we can create our SSH keys, SSH key generator, this is the command. Then you provide the name of the algorithm that you would like to produce. Then it will ask you a name. You will give your name SSH RSA. Then you will need to write a name here. Then it will produce your key. Then how we can upload our public key to the remote computer. Here one of the commands, scp, is a command to transfer data. Here the location of the public key. You remember, you always keep private key on your side. You will use it for authentication, and public key is stored in the remote server, which is used to verify our identity. And this is the server that we would like to connect. And Vera1 translates to Vera1, this host name. Then this is the location.sh authorized keys. Please don't use this command. If you use this command, you will overwrite authorized keys. But in your authorized keys in the remote computer, under authorized keys, we are keeping public keys. We may be using multiple keys to access this server. For example, this is the computer that I'm using at home, but I have a computer at work also, and we are using different keys, and both are stored here. If you overwrite this file, then you will lose your previous keys. So instead, I would suggest using SSH. SSH comes with several helper utilities. Copy-id. Copy-id command helps us properly to upload our file. SSH copy-id username at remote host. This helps us to remotely connect. And SSH copy-id -e. This is the name of the public key, and this is the remote host. Here is the command to securely send your data, because you need to also be careful to setting the permissions of the SSH directory. This directory should be always having this privilege 700, and all your keys should be read and write only for you. This means 600. Okay, this is quite important. So then we come back here. As you remember, we are using ZSH bash instead of bash when it comes to accessing an application running on Alvis. So let's get started. SSH Alvis 1. Now I connected to SSH Alvis 1. This is my desktop. In my desktop, I have two files. One is Emre environment, and one is our storage area that we use shared in our research. First and foremost, we need to create a virtual directory while running a Python-based application. Why? In virtual environment, we install dependencies of the applications that we are using. Once you develop code with Python, one of the first thing that you do, creating a virtual environment, right? So we are doing this also on HPC servers. In order to do this, as you can see, you shouldn't use directly pip install any tool on the server, because if you do like that, you will install to your account. But we want to install it to a virtual environment so we can isolate our operating system from our development. So in order to create a virtual environment, we will use this command, virtual environment. This is the version of the system. So normally we are using python-m virtual environment to create the virtual environment. Here the logic is module load virtual environment. Now I need to write the version. There are different versions. I usually use the latest version to create my virtual environment. Once you press enter, you will be asked for a file name, so you will have your environment installed. Then how we can use this environment? The same logic, source virtual environment been activated. I suggest you to create your environment with a name starting with a dot, so it's gonna be hidden on your desktop. You don't need to see. As you see, now we switch it to here. I can use pip install to install anything. cd image, here our files, and here is our folders. Here are the folders. So what we want here, first we want to run our large language model, right? In order to access this large language model running on a GPU, first I need to run this service. How I can run it? Template, start run. In the bottom of the script, we have our command sbatch template slurm. This is the command to run our service. Batch template. So it is submitted now. I will divide my screen into two. In the upper part, I can see the command that I have been running. Here, I always suggest you to monitor the output of your execution. The final file is this one. As you can see, this is an error message, information message coming from our template script, waiting server startup. It usually takes 3 to 5 minutes to fire up. Here, the most important part, as you know, we are using vLLM, right? But vLLM is not exposing services that we can easily access. So for example, if we were using Ollama, Ollama exposes large language model endpoints in a traditional way. We need to have a standard HTTP requests to access LLM components, LLM inference. For example, we are asking a question, we need to make a proper API call to this local LLM. But vLLM is not exposing these endpoints in a standard way. In order to convert vLLM requests to Ollama, we need to install an application. That's why actually we activated this Python environment first. We need to install a Python library which will intercept all requests coming to Alvis server and convert it to vLLM requests. So in our computer, we will make Ollama requests and Alvis will capture these Ollama requests and convert to vLLM. vLLM will send responses and this application, this proxy application will capture the responses and convert it to Ollama responses and send it back. So we have successfully run our node, GPU node. So our large language model runs on this server. Let's copy this endpoint and go back to our computer and try to access. As you can see, we cannot access to this endpoint. In order to do this, what we need to do, ssh-1377. This is the port number that we would like to open on our computer. The below terminal is on our desktop, not always. What does this mean? This command translates to first, SSH to Alvis 1, make an SSH connection. Second, create a network socket 1377 on the local computer and stick this port number to this port number running on Alvis. How this can happen? Normally, my local computer cannot access, but once we establish an SSH connection, through this SSH connection we can do this. Let's see, and now we try to access this server. I need to write localhost, right? /v1 models. As you can see, now we are able to access the model that we are running on the remote computer. As you see, this is our model that we can access from our local host. Why? We open this port number on our local host, which is connected to Alvis 10.07 int private. As you see, this is a private IP address we cannot access directly. But we can access, for example, curl paste v1 models. We can access the same result on Alvis by accessing this URL address. Here, one of the things that we should do together, as you see, I just access by using a browser, and accessing by browser and accessing from a Python code or application is not the same thing. In order to verify if we did our setup correctly, now I will run an application, a client application, MCP Desktop Assistant and MCP client application, which uses large language models. Here I use Fire, as you see. From providers, I will set my Ollama provider as this is the default port number 11434, but in our case we are using this one, right? Then let's see if we are able to access this model. Localhost, the same URL we write here, but we are not able to access it. Here, Command C, tail-f, vLLM out, and we can see the requests here. Actually, whenever we run our application, Fire client successfully sends requests to our model we can successfully access, but the problem is that URL does not found because API tags is a convention used by OpenAI. Normally, we need an application which converts requests to Ollama format. API tags is just to learn the model names to list here, but it says model not found. How we can overcome this problem? LiteLLM is an application that helps us to convert requests to Ollama format. Here we set our model name, Ollama GPT-OS 20 billion. This is the model that we would like to use on Fire. And we will convert it to OpenAI Royal Hacking Lab Dr. Emre Süren. This is the name of our model, as you remember from here, ID. And this is the URL address. We need to update our URL address because now we are using this number, right? Come here. We need to put v1 at the end. API key, we don't need an API key because it's a local model. This is the command that we need to run. LiteLLM configuration file. This is the configuration file, LiteLLM configuration -- port. How we can install LiteLLM? But we need proxy package. We need to install LiteLLM by using this command. Pip install LiteLLM, but normally we need to have this proxy. Exactly, full installation. If you want to run LiteLLM proxy server, we want to run as a proxy server. That's why we are using this convention. Here I'm not gonna run in source. Activate. Now activated, I can run the command LiteLLM config, LiteLLM config number. Yes, now it's running. Here still we can access with this command, but now what we need to do, get v1 models. As you see, we can access still v1 models, but what we need here, what does this do? First we connect to Alvis. On the Alvis, there is a service running on this port, which is LiteLLM, which forwards requests to vLLM. So now tunneling to here, we cannot access anymore, but we have now on this port, right? 100. Yes, we can access models here. Unfortunately, here we can't still, we are getting API tags. Normally we are expecting our LiteLLM to convert it to the endpoint that vLLM understands, but it fails. We need to study this one. Next, what we can do, we should fix LiteLLM problem. We can access from our terminals, but applications, MCP clients or desktop assistants cannot access these endpoints. That's why we need to fix this problem.